So next up, we have Siddhartha Daswani. Siddhartha is a 7th grader at the Harker Middle School in San Jose, California, and he will be speaking about a deep learning approach for open area smoke detection. So Siddhartha, I'm going to make you the host. You can go ahead and share the screen.
So, hi, my name is Siddhartha Daswani. I'm a student at the Harker School, and I'm in the 7th grade. So this is my presentation, and my project is titled "A Novel Deep Learning Approach for Open Area Smoke Detection." So I was really motivated towards this issue because when I was 10 years old, I personally experienced why wildfires are such a major issue in California. I remember the day very clearly. I woke up in my home in San Francisco, and as I looked outside, it was pitch black. This was in the morning, an hour after sunrise. Upon further investigation, I realized that the sky was blanketed with smoke so thick that the sun was blocked out. It was a surreal experience, and it really spurred my interest in wildfires. So why was this problem really important for me? We all know that wildfires are an issue, but they are a much bigger issue than we think. Wildfires cause more than 33,000 deaths and destroy over 10.1 million acres annually. Around 40% of the damage that is caused by wildfires occur in California, where I live. Every year, there are major fires that impact large groups of people. As the smoke spreads across the state, it makes it hard to breathe and causes school closures and health issues. Smoke from fires cause massive environmental damage. Fires burn trees and forests, turning them to charred ruin, and the smoke causes the ozone layer to weaken. So how did I build my AI? I first downloaded 332 images with smoke and 287 images with no smoke. Once I had my data, I used a program called Pixie to Navigator to train the AI. I used the ResNet 152 and MobileNet V2 algorithms to train my AI. I used different hyperparameters to tweak the aggressiveness of the AI, and I then made a table of my findings and determined that ResNet 152 was the best algorithm to use in my AI with an accuracy of 98%. So this is a diagram of the AI that I had made for one of the science competitions that I entered in. So first, the images are uploaded into a website. These images are sent to the AI. These images go through this process, and then it returns the result with whether or not it saw smoke in the image. So how did I get my data? I obtained data from public repositories such as GitHub. I used images that look similar to the terrain where I live because this was my target area. GitHub repositories are public, so they are useful for projects where you need large amounts of data. Why did I use AI? I used AI because AI can detect smoke without expensive hardware. In addition, AI is not jeopardized by human error. Once the input is given, the AI is fully autonomous. I used ResNet 152. ResNet 152 is a convolutional neural network. It was invented by Microsoft in 2015. ResNet is called ResNet 152 because it has 152 layers, as you can see here. One thing that really gives ResNet 152 its edge are these skips that it does, as you can see here, and that allows the AI to be faster and also more efficient. I also tried an algorithm called MobileNet V2, which was invented by Google in 2018. ResNet 152 did better in my experiments because it had a higher accuracy. So how did my solution work? I ran a lot of experiments where I tweaked the hyperparameters, and I tried several different algorithms. I was able to accomplish all my goals and meet my design criteria. I was able to make my accuracy 98% and have my AI send results within 3 seconds. I also have my AI fully accessible, so any device can use the AI, and they only require Wi-Fi to download the image. After that, the AI can be used in offline. So my AI detected whether or not there was smoke even with clouds. Here are examples of images my AI correctly predicted. This first image has no smoke, even though these clouds might be confused as smoke, as you can see here. This second image does have smoke, and the AI correctly predicted that there was smoke, as you can see here. So my AI was able to detect the smoke or no smoke in the images, even with difficulties such as clouds that may be confused as smoke to the human eye. So what did I learn? Wildfires are a very overlooked issue. A lot of research is dedicated towards preventing emissions, but 8% or a large amount of carbon emissions come from wildfires. Fire departments stick with antiquated methods of prevention. I learned that using AI, it is easy to detect smoke in images. So where would I like to take this project next? I would like to build an app. This would help with spreading the project and making it more accessible. It is important to spread the app because without user data, the project doesn't have any input. The app would also have capabilities such as notifying fire departments if fires are detected. Thank you.
Thank you very much, Siddhartha. Very nice presentation. So you have a number of questions. If you can return the host privilege to me, I'll read out the questions to you as well. So first question is, can this be used for other natural disasters, do you think?
Well, the area that I trained specifically, it has to find something in the image. So for wildfires, it would be looking for smoke. I think it could work for other natural disasters, but it really depends because some natural disasters like earthquake give no prevention, while some like tsunamis have signs that show. Okay. So it depends, but I do think it could be, if you train the AI with images that were images of like pre-warnings of tsunamis, you could use this AI or this method to detect other natural disasters.
Okay, very nice. And then the next question is, what distinguishes this model from other wildfire detectors?
So there are not very many wildfires detectors that are pure AI. Many of these use things like thermal sensors or expensive cameras, huge amounts of hardware that cost huge amounts of money. My AI is unique because of the fact that anybody can use it from their phone. This is really important to me because of the fact that there are places in third world countries where there's really high weather or really high heat, and the environment is really, it's at high risk for wildfires, but there aren't solutions because they can't afford them. So that is why the fact that this is completely, like it requires no unique hardware, that's what makes it unique.
Makes sense. And then I think there's a question, was all the data from California?
No, the data wasn't all from California. It was from across the world. But the images that I chose were specifically, they looked like the terrain in California because I wanted to first make the AI more focused. So there would be a bias if you went and tried to use the AI somewhere in a desert. It wouldn't be able to pick up wildfires as well because it's being trained with things like forests, hills, grass. So there is that bias, but the images aren't all from California. And if I wanted to eliminate the bias, all I would have to do is train with images from other places.
Makes sense. And then the final question is, there are some black borders on the corners of the sample images that you showed. Do you know where those came from?
Let me go back to that. These images, so these are trail cams. Trail cams often don't have like the best camera quality. So this is just a cutout from the camera itself. So there might have been a cover on top of the camera, and that's why there's this black outline. So yeah.
Wonderful. Well, thank you very much, Siddhartha. Very nice presentation. I think, let me see if there's any other questions. No, I think that's it. Thank you so much. Terrific. Nice job.